everyone, my name is Anissa Yustika Mulia Putri. As the presenter of my team consists of Mrs. Endar Nordiartanti, Mr. Arif Jumari, Mrs. Tika Paramita, Miss Sofirul Solihatunisa, and Ms. Nurmas Noriati. And I will tell you about our experiment titled Synthesis and Characterization Cellulose Acetate Membrane from Cigarette Butts as Polymer Electrolyte for Lithium-ion Battery. Separator of lithium-ion battery, or LIB, is a solid-phase electrolyte membrane which separates anode and cathode electrolytes, both optimizing LIB ionic transfer and making sure there will be no internal short circuit. We should have a good properties of separator. PVDF is commonly and widely used as separator. They have good mechanical and thermal stability but have high degree on crystallinity that can reduce the separator performance. So we need to modify the PVDF separator membrane. So what to combine on this modification? We choose to use cellulose acetate or Ca because their good properties match with LIB separator characteristics such as good fiber matrix, good thermal stability and electrical insulation, and high pressure stability. Their hydrophobicity and low thermal conductivity will reduce the degree of crystallinity, and this is good for membrane manufacturing. As the sources of the cellulose acetate, we choose to use cigarette butts. Why? Because cigarette butts contains the most cellulose acetate compared with any other Ca sources such as banana waste and cassava stem. And this utilization of cigarette butts can help to reduce the environment problems. By combining PVDF and cellulose acetate, we will combine their good characteristic as well, so they can cover each other weakness. The decreasing in the degree of crystallinity that leads to a good manufacturing membrane, we will produce a good characteristic membrane too, so the performance of separator can be improved. The result of the similar modification before has shown that they have dimensional stability and good ionic conductivity, and this leads to competitive LIB performance. So how to modify this separator? We will add cellulose acetate into the slurry contain PVDF and any other component, and then the mixture will be casted on a glass-like surface, and this method is relatively low cost and doesn't need many equipment. So there are the material we use. They are cigarette butts, toluene, ethanol, acetone, DMAC, PVDF, ZNO, PVP, aquades, normal butanol, and electrolyte. First methodology is to recover the cellulose acetate from cigarette butts. We wash the cigarette butts to separate the tobacco and the wraps from the cigarette filter by adding aquades, and we will purify them into chocolate purifying by adding ethanol and toluene. We will get the residue and we will dry them into oven within 12 hours and mix them in acetone and precipitate them into aquades, and we will dry them on oven drying, and we will get the precipitated cellulose acetate. The second is to manufacturing the membrane. We use casting manufacturing. We will add the precipitated cellulose acetate into the slurry of PVDF, PVP, DMAC, and ZNO and mix them within 4 hours. And we will cast them into a glass plate-like surface and immerse within 12 hours in aquades. And then we will dry them by air drying, and we can analyze the membrane characteristic, and we will get the electrolyte membrane. The first result is the yield of Ca recovered with ethanol by toluene as solvents variation. We obtained the highest yield at 95.43% in the first variation. It is the ratio of solvent ethanol by toluene is 1 by 1.0. This is the result of XRD analysis of cellulose acetate. We compare the cellulose acetate from cigarette butts with cellulose acetate commercial powder by XRD analysis, and they show similar peaks. Then the FTIR analysis of Ca from cigarette butt extraction was also compared with commercial Ca, and they show similar peaks too. This is the result of same analysis of cellulose acetate. The result shows that Ca has membrane-like surface morphology, and this may be caused by the morphology of cigarette butts. The result of the electrolyte membrane separator, the first is porosity. The porosity of the membrane is determined based on the empty volume of the membrane. The empty volume in the membrane can be calculated by determining the amount of the volume occupied by N-butanol. And the highest porosity value of this experiment reaches 79.047%. The electrolyte uptake of the membrane was determined by calculating the ratio of electrolyte solution absorbed by the polymer membrane to the dry membrane. The highest electrolyte uptake value of the experiment reaches 942.107%. This is the result of electrolyte membrane separator XRD. The result shows that there is PVDF and Ca in the electrolyte membrane separator, which is made in various composition. And the FTIR result of the electrolyte membrane separator shows the presence of PVDF and Ca functional groups extracted from cigarette butts too. This is the same result of separator membrane, and this identify the morphology of electrolyte separator membrane and show that there are agglomeration pore arrangement in the membranes. The conclusion of this study is the extraction of cellulose acetate from cigarette butts and the manufacturing of PVDF Ca-based membranes with PVP and ZNO additive was conducted to be used as separator in lithium-ion batteries, varied in the composition of PVP and cellulose acetate. The extraction of cigarette butts produced cellulose acetate with a yield of 95.43% in 1:1 solvent ratio, 88% in 1:1.1 solvent ratio, 79.58% in 1:1.2 solvent ratio, and 68.90% in solvent of 1:1.3 ratio. Meanwhile, the PVDF Ca-based membrane with a composition of 4% PVP and 10% Ca had the best characterization result with an electrolyte uptake value of 942.105% and a porosity value of 79.047%. Our team as the authors greatly acknowledge the Kemendikbudristek for a research grant award through the penelitian dasar unggulan perguruan tinggi grant nomor 11 /S1/KP.PTNBH /2021 and nomor 221.UN-27.HK.07.00/2021. The authors also thankfully acknowledge the Center of Excellence for Electrical Energy Storage Technology, Universitas 11 Maret, for the help and assistance with this experiment. The last is the reference we use in this experiment. So this is the end of my presentation, and thank you for your attention.